we're going to look at this new concept called the chain rule, which helps us to differentiate functions which we haven't quite seen just yet. If you look at the previous examples, for example, a function like this, y equals 3x squared plus 5x take away 6 over x. This type of function is easy to differentiate, right? Because all you need to do to find the gradient function, dy by dx, is to just differentiate each little bit, right? So this would be 6x, this would just be the number 5, and this would be, let me work it out, I'd have to rewrite it as 6x to the power minus 1, so that'd be a plus 6x to the power minus 2, right? So we just differentiate each little bit. Dead easy to do. But functions like this are a little bit hard to do. So, I mean, how would you differentiate something like this? You know, y equals, in a bracket, x cubed plus 5x to the power 7. Or something like this, x cubed plus 3x all square rooted. Well, you may think on this one, okay, I could do this. You know, you write the binomial expansion out of this and then differentiate each little term. But, you know, if you think about it, there'll be 8 terms altogether. And you've got this x cubed and this 5x, and there'll be a lot of calculation there. And it may take you a long time to do, and there's a big chance that you could go wrong somewhere, okay? Because of the binomial expansion method itself. This function, I wouldn't even know how to do it. You know, it's the root of x cubed plus 3x. You may think of rewriting it as maybe x cubed plus 3x in a bracket to the power of a half, and then maybe doing something with that. Still, it's quite difficult to do. So what we're going to do is we're going to use a method called the chain rule to do this. And how the chain rule works is like this. This is the rule you'll see in your formula booklet. Okay, this is the chain rule itself. If you want to find dy by dx, then that's equal to dy by du. Okay, so the derivative of y with respect to u, okay, we've looked at that before, times du by dx, the derivative of u with respect to x. And this is the chain rule itself. Okay, we're going to use this to calculate the derivative of the functions we just saw in the corner over there. Now think about why this works. Okay, what we have is, okay, these are not strictly fractions, okay, dy by du times du by dx, but just think about theoretically what cancels out here, okay? And this is why it works. If you had something like, I don't know, a over b times b over c, well, because we have a over b times b over c, and you've got b on top and bottom, what cancels out is the b's, and what you're left with is a over c. And that's kind of like what's happening over here, even though I'm strictly not allowed to put a line through these du's, okay? I'm not allowed to do that, but that's sort of what's happening here. Think about putting a line through these du's, you have a dy by dx. Okay, so that's let me rub this out because this is like really bad. I really shouldn't be saying this at all. I could get in some trouble with this. But this is the chain rule, and this is how it works. And I'm going to show you how to do this. And it's all about using composite functions, because if you look at it, these two functions over here, they're actual composite functions. Is a function inside another function. So let's go ahead and differentiate these. Okay, so the first one, number 1, was y equals 3x squared plus, is it 3x squared? Oh, I'm just making it up, right? 3x squared plus 5 to the power of 7. Okay, now here's a trick. Sorry, it looks like a composite function. And what we want to do is create a new function, okay? I'm going to make a new function called u. And I'm going to let this be the inside bit here. Okay, I'm going to let this bit be the 3x squared plus 5 bit there. Okay, so u is a new function and it equals 3x squared plus 5. So what would y become now? Well, y, if I replace this 3x squared plus 5 with the letter u, because I've just said let u equal this bit here, then it would be u to the power 7. And if you think about why that is, if you take this, u equals this now, and if you take that and put it where you see the u to the power 7, you just get this. Okay, so what we've done is we've taken y and split it into like a composite function. And what we're going to do now is we're going to differentiate each one of these two. Okay, so what we're going to do now is we're going to differentiate y with respect to u. So we're going to work out dy by du, which would be, alright, so differentiating y with respect to u, that will be 7 comes to the front, 7, let me do that again, 7 u, and the power drops by 1, you take off 1, so 7u to the power 6. And we're going to differentiate this function du by dx with respect to x. Sorry, we're going to differentiate u with respect to x. So what happens here? 2 multiplies the 3, so we have a 6x, and the power reduced by 1, and the 5 just disappears. So what we have is dy by du is 7u to the power 6, dy by dx equals 6x. And what does the chain rule say? Well, the chain rule says if you want to find the derivative of y with respect to x, which is what we actually want, we want the derivative of y with respect to x, well, that's the same as doing dy by du times du by dx. Okay, think about what cancels out here, but what is dy by du? We just worked it out here, 7u to the power 6. So I'm going to bung that here. So that equals 7u to the power 6 times, what's dy by dx? Dy by dx is 6x, so I'm going to replace that with 6x. So I need to clean this up a little bit. So what can we clean up, and what can we sort of bring together? Well, I have a 7 times 6, which is 42, x u to the power 6. Okay, so at the moment this is what dy by dx is. Okay, 42 times x times u to the power 6. But the thing is though, I want my derivative function to be entirely in terms of x. Okay, so what I need to do is this. I need to replace this this u here with what I declared earlier. And what was u? U equaled that bit, it equaled 3x squared plus 5. So what I'm going to do is I'm going to replace this u here with this, and then I've got a function entirely in terms of x. 42x, I'll have to put a bracket in now, 3x squared plus 5 to the power of 6. And that is my derivative function in terms of x. So that's the derivative of y with respect to x, entirely in terms of x now. So you differentiated it. So you can then go and work out the gradient of this function any way you want. So even if you actually did the binomial expansion and then differentiated each term and then sort of compared it to this, worked out the binomial expansion and multiplied by 42x, it'd be the same thing, they'd match. But it'd just take a long time. This took about, well, I don't know, a couple of minutes to do, whereas the other method would take a long time to do. Okay, let's look at one more if I've got time. I'm trying to keep this under 15 minutes. Y equals 6 over square root of x cubed plus 3x. Okay, now we're going to do the same thing. We're going to split this up into composite functions, but it's all about getting the right two functions. You don't want to cause too much work for yourself. Okay, so I'm going to let this bit under the square root equal my u. So let u equal x cubed plus 3x. Okay, so then what would y equal? Well, then y would equal 6 over square root of u. Okay, and then if I replace the u with x cubed plus 3x, I'd get my initial function here. Alright, so what we're going to do is differentiate each bit. Okay, so I'm going to, well, first of all I'd have to rewrite this. I'd have to rewrite as y equals 6 u to the power of a minus a half. Okay, so now let me differentiate it with respect to u. Well, the minus half is going to multiply the 6, so I'd have a minus 3, and then I'd have a minus a half, take away 1. Okay, so that'll be minus 3 over 2. Okay, so minus 3 u to the power minus 3 over 2. Okay, and then that's the derivative function of that. Let me differentiate u here, and it will be a 3x squared plus, what's that, just 3. Okay. Now to find the derivative of this, all I need to do, I need to multiply these two functions. Okay, so dy by dx equals this one, and it actually doesn't matter which order you multiply them in. It really doesn't matter. Minus 3 u to the power minus 3 over 2. Oh, my handwriting's really poor. Minus 3 over 2 times, I'd have to stick this in a bracket, by the way, so 3x squared plus 3. Okay, and that's the derivative function, but remember, we want the derivative function entirely in terms of x. Now I'm just going to reorder this because you can, and it doesn't really look neat as it is. So I'm going to do minus 3 bracket, I'll put that bracket 3x squared plus 3. You can do this because it's just a string of multiplications. It's minus 3 times u to the power minus 3 over 2 times this bracket. Times, well, okay, I'm just going to do this in one go, but you figure out why this is. That u I'm going to replace with this, because that's what u is. U is x cubed plus 3x. So new bracket, x cubed plus 3x to the power of minus 3 over 2. And there you go. Can't really clean that up anymore. I could maybe multiply each one of this bracket by minus 3 if I wanted to get rid of it, but I'm not going to bother. So that is the derivative function of 6 over root x cubed plus 3x. Okay, that's it. And this is how you have to do it. But it's all about getting the two functions here correct first, because what you don't want to do, sorry, is do too much work for yourself. So I could have done 6 over u and then let u equal the square root of x cubed plus 3x, but then that would require more work. Okay, so this reduces the amount of work you have to do. So that's the chain rule, and it's great for differentiating composite functions. So when you have a composite function like this, a function inside another one, you have to use the chain rule. And the good thing about this is that you don't need to memorize this, even though you really should do. It is in your formula booklet, okay, so you can look this up. Okay, but in the question itself, it may not explicitly say use the chain rule. You've got to figure out that, hang on, this is a composite function, and if I want to differentiate it, the only thing I can do is use the chain rule. Okay, we're going to use this a hell of a lot, so practice this in the relevant chapters.